So, like I was saying yesterday, it's up to you how you'd like to do this. There's two different ways. Okay, so one way is to, at this point, finish multiplying what's left on both the top and the bottom. So here, it's 18w cubed on top. And 24w squared and w minus 1 on the bottom. That's one way, and then you can simplify from there. The other way, like if I'm doing it myself, generally speaking, I kind of count up what's on the top and the bottom for if there's common things. So there's w's on both the top and the bottom. So I'd be like, okay, well there's 1, 2, 3 on top. So I count them in total. So that's 1 over with the 2 and 2 with the 9, so there's 3. And there's 2 on the bottom. So I am able to cancel off 2 of them. Okay, I'm like, okay, I know the w's. 2 w's can cancel. That's what I would normally do. And then I would also say, well, okay, 2 and 4 can both be divided by 2. And 9 and 6 can both be divided by 3. I would do stuff like that personally. Because I can keep it all in my head and I can do it out. So I can see that the only thing left on the top is w. And on the bottom I would have 2 times 2 is 4, w minus 1. And I can do that all at once. If that's something you're able to do, great. If not, go with this method and then continue to simplify. So here I would divide by 6w squared on both the top and the bottom because you can. Actually, 18, 24. Oh, sorry, I missed a 3 here. So there should have been 3 there. So I end up with 3w over 4w minus 1. So I do get the same answer either way. And we did our non-permissibles earlier. So whatever you feel comfortable with, I kind of think this way is more procedural and is more like probably what most people like to do. So simplify things out, like multiply everything together, and then look to see again what can be taken away is a good strategic way to do it, step by step, making sure that you get the right answer. Okay, so after you've canceled off some of the common things, then you can do that. And it's a nice way to look at it. So let's just look at a few more problems. I know we've looked at a few. Let's take a look at a few more. So this is a multiplying one. So remember, dividing, the only trick is that you have to flip the second term. With multiplying and with dividing both of them, one of the very first things I have to do is always going to be to factor. So if you are doing a problem and you're like, I don't know where to start, chances are the starting place is to factor. If any factoring can be done, you should do it. So here, in the first expression, I have x plus 1 over x plus 3, and that can't factor. There's nothing there that can factor out. Now, in the second expression, what can factor in the top? 2, so I have a 2 out front. And what will be in the brackets? X plus 3. And on the bottom, what can factor out of x squared plus x? And x. So I'll have x, and in the brackets I'll have plus 1. Now at this point, this is when you take a moment and you cancel off the common things. So here I have lots of common things. What's common between them? X plus 1 and x plus 3. So all that's left up top is 2, and all that's left on the bottom is x. Okay, so lots cancels there. Now here, if you're doing the non-permissibles, you do it all the time from this step. Okay, you don't look at the very end. Because if I looked at the very end, I would be like, oh, x cannot equal 0. That would be the only one. But that's not actually the case. You have to look at it from the step after you factored. So 0 is one of them, because that's there. But there's 2 others as well. There's x plus 3 and x plus 1. So what would be my non-permissibles that go with those? Negative 3 and negative 1. Okay, so all 3 non-permissibles would go there. Okay, simple enough. It's pretty straightforward. Okay, so we've looked at it kind of like this. I want to look at one that isn't quite like that, because I actually find these ones are easier, but I find students are like, Man, I have no idea what to do with this one because there's no factoring. So here, on this one, 6x cubed plus 18x, or sorry, 6x cubed over 27x4 times 18x over 15. There's no factoring. I can tell there's no factoring because everything's just one term there. You can't factor something when there's only one term. Now here, probably the best thing to do is to multiply out the top and the bottom. That's going to be the thing that most people probably find the easiest. There are other ways, and if you're someone who who's feeling like really good about this stuff and wants to look at some quicker ways, you can ask me about it. But here I would go 6 times 18 is 108. So it's 108. How many x's would I put up there with the 108? 4. Okay, because there's 3 and 1. And on the bottom, I have 27 times 15 is 405. And it's also x to the 4. So those x to the 4s are going to end up canceling off. Okay, and you can either cancel them or you can think of it as dividing by x to the power 4. But what we really have to come up with now is the largest number that goes into both 108 and 45. So, or sorry, not 45, 405. So your calculator can actually do this for you. If you just type in to your calculator 108 over 405, and then you hit math 1 for fraction, your calculator will just spit out the fraction in its lowest terms. It's 4 over 15. And if you want to figure out like what that actually means, it means that 108 is divisible by 27. Because to get 4, I would have to divide by 27. So if I divide the top by 27 and the bottom by 27, I would get 4 over 15. Okay? I could divide them both by 27 to the power of x to the 4. Okay? And then I get 4 over 15. Okay, as a final answer. So your calculator can do that for you. It can give you that 4 over 15 if you're someone who has trouble coming up with those numbers. Another way to get that 27, just so people know, is I could realize that 18 and 27 are both divisible by 9. And 6 and 15 are both divisible by 3. Well, what's 3 times 9? 27. I could see that earlier if you were someone who can spot things like that easily. If not, use your calculator. Do it out just procedurally and kind of do it out. If you have really good number sense, though, you can kind of figure things like that out by looking at the earlier problem. Now, what would the non-permissible value here be?
0.
It is 0. So again, you don't look at the very last step. Like if I just looked at the last step, there wouldn't be any because 4 over 15 doesn't have any. But you look at the middle step here, or even the first step, and I can see that that there would give me a 0. Okay, so that's how you do it when it's not factoring. This was not factoring. This was one where we're just given the numbers and we just have to simplify it and divide by something. Okay, so let's look at, here, I just want to look at this one just because this one already has part of it factored for you. I find students, like, when they see stuff like this, sometimes they're like, I don't know what to do with this. This one, it's nice. They factored one of them for you. That's why on, down here, that part there, that's already been factored. So you don't have to do it. That's all it means. Okay, don't expand it. I see students expand it a lot. Like, students will write that as x squared plus 3x. Which is true, but like you're working backwards then. Okay, so leave it how it is. So just factor everything else. So x squared minus 9. What's x squared minus 9? X minus 3x plus 3. And that's called difference of squares, and you need to know how to do it, and you need to recognize that that's what you're dealing with. So if you have x squared minus a number, that's probably what it is. It's probably difference of squares. Okay, over, what's going to factor out of the bottom? 6, and what will be left in the brackets? X plus 4. Okay, times, then on the top there I take out a 10, I have x plus 4, and the bottom's already been done for me, so I don't delete what's been done, I write it out again. Then I look for common stuff. So what's common on the top and the bottom? x plus 3, and x plus 4. Okay, then you write down what's left. So what's left is I have 10 and x minus 3. And don't multiply them together. Just write them next to each other. Like that. And on the bottom, what do I have left? 6 and x. So I have two things. And again, I just write them out like next to each other. 6, x. Okay. Now, this can be simplified a little bit more. What else can be done here? I could divide by 2 on the top and the bottom. So you look at the front numbers here, and if they can be divided by anything, you need to do that. So here I do need to divide them both by 2, and you could have done that up at the top. Like if you noticed it, you could have done it here. It would have worked just as well. But as long as you do it eventually. So it's 5x minus 3 over 3x. And the non-permissible values here, there's 3 of them. And I look back up at this step. So they are, what are they? 0, negative 4, and not negative 5. Negative 3, yeah. Okay, just mistaking the number. Okay, so those are them from that step when you factored. Okay, and that's it. So it's not that bad. It's just a lot of factoring, then canceling. Okay, trust me, when we start doing adding and subtracting, you'll be like, man, multiplying was easy. Okay, well, good old days. Okay, so let's do a couple divisions. Then we'll have some time to work on a practice of this. So if we're dividing, what's the rule again? You flip it, and you just flip the second one. Okay? So not the first one. I had a student in my grade 9 class today ask me if I was sure about that. And I'm pretty sure. So you flip the second one and you multiply. Okay, so when you flip it, you change the sign to a multiplication. Now you do it just like the other one. So I would multiply here. So I do 6 times 30 is 180. X to the power of 5. And on the bottom there, 15 times 12 is 180, probably. Well, that would be interesting, because they'd be the same then. I'm going to make sure. Okay, it is. So 180x. So there, what can 180 and 180 both be divided by? 180. So we can divide by 180x. So once we divide by that, on top, what will we have left? X to the power of 4. And on the bottom, we will have 1. Now, you don't need to write that 1. So you could just write x to the power of 4. Okay, and then here, x can just not equal 0, because there's nothing else going on. But remember that you need to, with division, look at all 3 parts. But they're all 0 there, so it doesn't matter. Okay, now this one's, I wanted to show you this other one here specifically because it's a little tricky. The second number isn't a fraction. So does anyone have any idea what I would do with that? Make it a fraction by doing what? Put it over 1. So when I flip it, okay, it becomes 1 over 18x squared, and it's really no different after that. I just wanted to show that just in case somebody was having trouble with that. So it's 14x over 162x to the 7. Now my guess is that they're both divisible by 14, but I would check on my calculator. So it'd be like 162. Actually, you know what? They probably aren't. Well, let's see. Nope, they're not. So what else is 14 divisible by? 7. So I would check if 7 works. It doesn't work, so that means that that is actually in lowest terms, that there's, well, I guess no, a 2 can come out, obviously. So divide by 2, and x, I almost thought it was in lowest terms. Divided by 2x and divided by 2x. So we get 7 over 81x to the power of 6. Okay, and that looks good. And if it takes you more than one step to get to lowest terms, that's fine. Like if you divide by 2, and then you're like, oh, it's still divisible by something. Like, fine, do it again. Like, it's not a big deal. It's just like when you were little. Sometimes it took a couple steps to get to the final fraction. just continue to look at it and ask yourself what can be taken out. Okay, so yeah, that's divided. Let's do more of a harder one, and then we'll move on. So this one's quite hard, this last one here. I mean, it's not, I don't know, it's not like impossible or anything. It's just kind of hard because there's quite a bit of factoring to be done. So the top factoring there, the 4a squared minus 1, what does that factor to? Does anyone know? It's going to be 2a plus 1 and 2a minus 1. That's difference of squares. Okay, 4 and 1 are both perfect squares. And 4 and 16 are also both perfect squares, but 4 and 16 also have a common factor, and you should actually remove the common factor before doing difference of squares. So 4 and 16, what goes into both 4 and 16? 4. So if I take that out, I'm left with a squared minus 4. And then I would go ahead and I'd flip it on top, so it's 2 minus a and 2a minus 1. Now this can still be factored. That's why this one's so tricky, is because it's a two-step factoring problem. It has two different things you can factor. So if you factor a squared minus 4, it's a plus 2, a minus 2. That would be a really, this is pretty much as hard as these questions can get at this level. Like still keeping in line with the program of studies or whatever. So that's it fully factored, which is hard. I would expect most people not to be able to get that fully factored form, which would mean a lot of people would get the question wrong probably. Now at this stage you are looking for common things to cross off. What do these two have in common? 2a minus 1, that's something for sure. Anything else? A minus 2 and 2 minus a. So we did talk about that the other day, that they can cancel, but they're not identical. So what do you have to do if you cancel them? You have to make it negative. So all you do when you cancel something like that is you add a negative out front. Okay, so all I would do is I would write a negative up there, like negative 2a plus 1. I don't get rid of my brackets. My brackets are still there. Over, what's left on the bottom? 4 and a plus 2. And that's the final answer there. Now here, the non-permissible values, I have to look at this whole thing. That's a lot to look at. There's a lot of factors in there, because for division you have to look at all three sections. So I have a plus 2. What's the non-permissible for plus 2? Negative 2, so it can't be negative 2. I had minus 2, so it can't be 2. I had 2a minus 1. Negative 1 over 2? It'd be positive 1 over 2, because you have to add the 1, then divide by 2, so it's a half. And the top one there, 2 minus a, would again be 2, so I don't need to repeat it. Okay, you only write it once. So that's dividing.